So, may I start sharing the screen?
Firstly, I would like to welcome you all for today's session. And in today's session, we have 8 presentations by the practitioners, making it extremely meaningful. As working on the ground with teachers, students, teachers in making use of plethora of experiences, which on analysis provide great insights. So we are looking forward to an enriching experience with you all. And I would like to express my sincere gratitude to all the speakers for showing interest in presenting their work at MTA. MTA is a platform for teachers. It is for teachers to learn from each other's experiences. And I sincerely hope that we will have a lot to learn from each other in today's session. So I extend a very warm welcome to all the speakers on the behalf of MTA. I will also quickly tell you about the format for the presentations. Each one of you will get 10 minutes to present, and the order of the presentation is there in the chat box. And after all the presentations, we'll have the question answer round where we'll interact with the speakers. So I request all of you to post your questions or comments on the chat box, and we'll collate them, and towards the end, we'll do the interaction too. So I would first like to invite Dr. Jasmeet Kaur, Mr. Singhal, and Mr. Sunil Bajaj for their presentation. They will be talking about developing a community of mathematics BRPs and ABRPs for the teacher support. And over to you, Dr. Jasmeet.
Thank you, Jyoti. Am I audible?
Yes, please.
Yeah. Okay. So first of all, thanks a lot for providing us the opportunity to share this work, which we are doing at SCRT level. And it's not a very, it doesn't have a long history. It is recently started after I joined SCRT 3 months back. I was also working as a teacher in the government of Haryana. So the topic here is we are into the developing a community of mathematics BRPs and ABRCs for teacher support. Now, what are, just a moment. What are BRPs and ABRCs? So in Haryana, BRPs, which we call as block resource person, and ABRCs as assistant block resource coordinators, these are basically the contractual employees and non-teaching basically, but they have lots and lots of administrative plus mentoring of elementary teachers work. So they are supposed to mentor teachers from grade 1 to grade 8. Apart from that, there is a long list of their responsibilities and roles. But here I've just mentioned that they have to coordinate for all kinds of activities which are there in the district and state level. They are also supposed to support head teacher for even writing the emails, giving the replies and all. And also they also handle lots and lots of data. Sometimes they have to also work as data operator. So yes, they are into much more into administrative duties than the mentoring. But yes, this is one of their role. So if I say what mentoring of elementary teacher, what does it includes? They have to visit, they are assigned some schools where they have to visit. Like for example, in a month, they will be visiting 5 to 6 schools they are assigned to. They have to observe the classes of the assigned schools, give feedback to teachers, find the learning needs of teacher, and they are also supposed to talk about various pedagogical issues with teachers, and also to provide the model lessons if they see there are very many difficulties in the lesson going on. And now, why did we start up with BRP and ABRC? Because Haryana is a very diverse state. I mean, the districts are diversely spread out. So it's not possible for us to reach to all the teachers. But yes, these BRP and ABRCs are in contact with teachers, and we thought that we should build a community so that the intentions and what we are expecting now in the pedagogy, it should be conveyed to the teachers in a better way. And these are the challenges which we found. And this is another reason that we have started with this. as this is a worldwide problem that the conventional approach, because teaching is considered as a cultural activity in India also, like in Haryana also, there is major focus is on explain, example and exercise. I mean, telling is the best way that teacher consider that. When even I talk to teachers, they say आप जो मर्जी गतिविधि करवाते रहें, जब हम एक्सप्लेन करते हैं तभी बच्चे को समझ में आता है, और यही बेस्ट मेथड होता है. मतलब they have this strong belief exist into their. And another thing is that primary textbooks they are not at all understanding what is it about. When we talk to teachers या BRPs जब बात करते हैं, they said समझ में नहीं आता इस बुक में क्या है, कभी अचानक से खेल आ जाता है, कभी अचानक से कोई प्रश्न आ जाता है, और कभी कहानी आ जाती है. We are totally confused with these books. So these kind of responses are there. I would have drawn the quotes also, but there was no time, so I just pointed out. And another problem is that BRP and ABRCs are not involved in teaching, but they have to support teachers. This is another challenge because they actually do not know the nitty-gritty of teaching and how that experience of teaching somewhere adds to the pedagogy. So they have to trust on their theoretical background. They need to have a very strong theoretically sound knowledge to mentor the teacher. And another thing is that BRP, ABRs are not themselves clear with the primary maths textbook approach. So what we have started with that at present, we have started with a group of around 40 we chosen, 2 from each district, but now we are left with 38. We do weekly online meeting with them, because it's not possible to call them face to face because they are from all the districts. In the online meetings, we do the discussions. They do some problem solving or some task which we design. They are also supposed to do field trials for what they do during the interactions, and we are also making them read some of the good readings. But right now, at present, we are doing the Divas Swapna in the weekly meeting. Now, what are the persisting beliefs among teachers and mentors are that I have already explained that बच्चा सिखाने से ही सीखता है. तो ज्ञान का सृजन जो हम कंस्ट्रक्टिविस्ट अप्रोच की बात करते हैं, they do not believe in that. And activity and games which are there, they are only to they can only be used to supplement either after explaining the content or concept, or they may be used it before introducing the concept. Before explaining the concept, only for the joy purpose or just to make them interested to learn the concept. तो दो ही कारण है उनके लिए एक्टिविटी या गेम्स के, just to supplement it, क्योंकि बच्चों का इंटरेस्ट बन जाए. But yes, it can be there for the concept formation that is not into their dictionary. Now, scaffolding required for first thing which we realize during the interaction is that they the kind of situation or the task which are given in the primary textbook, an understanding has to be developed that these tasks develop the concepts of the children, and they can be introduced without explaining. When it is most of the teachers are not using textbooks, but those who are using, they first explain it through the textbook, and they can't give the task like we give in the group and we ask them to, yes, you can do the task. And second scaffolding which is required is for opening the mathematics. Like mathematics may have open problems because they think that there is a one right answer and one right solution for that. So these are the two main things which we thought we need to give the scaffolding first. So there are a lot many other things, but I'll just describe here about the 3 tasks which we did. Like this is the one of the tasks which we did in our session. This is in grade 1. In grade 1 and 2, we are using textbooks developed by Haryana only. So there is one task, kitne meri muthi mein, and this is just a picture of it, but I'll show you that when we did it with the BRP and ABRCs first, and then we asked them to try it out with some students. There is a just 1 minute video. Just a moment, I'll just click it here. I think I need to share the. Give me a moment. I'll just share the sound also.
सेवन है, वाह बड़ी इंटेलिजेंट हो। आज हम एक खेल खेलेंगे, ठीक है? अच्छा, अब ना ये सेवन थे ना, अब बताओ मेरे हाथ में कितने हैं, मुझे बताओ, गैस करो, देखिए कौन जीतेगा। दो? कैसे पता है? अच्छा, ये कितने बचे? और मेरे हाथ में कितने हैं?
So, sorry. So if you see this video, you can see that here also the focus was not to ask students about how did they come up. Like she asked once कि अच्छा कैसे पता चला, but then she gave the prompt in a moment कि वहाँ पे गिनो कितने हैं. So this is a task which actually helps to develop addition and subtraction concepts both. I mean, students may use counting up strategy or they may do the takeaway strategy. They can use both here. But this was in the task, the focus was कि बच्चे जल्दी से सीख जाए. So in focus assumptions which were there before doing the task, which we observed while the discussion. क्योंकि when we ask them to actually record whatever you are doing, and those recordings were played during our discussion, and then we did the thorough analysis and discussion on that. So in focus, what were the in focus assumptions before the discussion? They used to think, I mean, mentors, they think that children must do this task in one go. I mean, there should be no time taken by them. This task should had that potential. Teacher need to tell them if they are not able to respond. I mean, they think that it is the responsibility of teacher that they should explain for as soon as they are not responding. And they were when teachers were actually were asked to prepare the video for that, and they observed that students of the lower grade were not able to do the task. They applied it for the higher grades. They said कि छोटी क्लास के बच्चे नहीं कर पा रहे थे तो हमने higher grades पे किया. So, but what could be the solution if these grade 1 children are not able to do it at a first go? Then what should be done? That was not into their focus. That what can be done with that. It is the teacher or adult who will be doing the task with the children. I mean, this is another assumption that this is the only teacher or the adult who will be doing the task. Children in the group are not supposed to do it. I mean, they can't do it. They think that. But after the discussion, what came, I mean, these were things that was there out of their focus. Okay, challenge jo hai, if we reduce that, then lower grade would have responded properly. Like at one go, they used 7 pebbles. If lower grade students are not able to do it with the 7 pebbles, they would have taken 5 or 4, or even they could have reduced the challenge. So this was not there in into their focus, which was developed after the discussion. Or giving more time, as when we go for a constructive pedagogy, it is time taken, and it takes time to actually students think and come up with their own strategies. So these kinds of yes, another problem that to take out the student strategies was not into their focus. के बच्चे से पूछे कि उन्हें कैसे पता चला, that is not at all of their importance. But after discussion, they realize that it is important. This is another task which
Jasneet, we are actually enjoying your presentation, but 10 minutes are over. If you could quickly sum up, please.
Yeah. So there are another 2 tasks which we did with our teachers, and this is a V task. 1 to 5 they were supposed to fill, and they were sent into the breakout rooms, and they did it. But yes, there are also in focus and out of focus assumptions, and how then they were asked to reflect on these tasks, which where they were asked that how do they feel when they did the task. In here, they did the task in the breakout room, and we found that there were some good inputs from the teachers. Like when they did it, they realize the importance of constructivist model of learning. This is another task which we did, kitne varg. There are also many challenges. I mean, this heated lots of discussions, like क्षेत्रफल क्यों इंट्रोड्यूस कर दिया, क्षेत्रफल को इंट्रोड्यूस किए बगैर कैसे टास्क दे दिया, क्षेत्रफल का मतलब तो बच्चों को पता ही नहीं है. तो such kind of challenges were there, and there is a trajectory in focus क्या था, out focus क्या था, और after discussion in focus में क्या आया. So conjecture we could make that if they do the task themselves before actually trying it out into the field, they do it better. I mean, एक तो है सिर्फ एनालाइज करना टास्क को, और एक है वो खुद से करें पहले. So when they do it themselves, तो they think more deeply into that. But yes, there are persisting challenge that how to convince teachers for that. There was also lots of discussion on that, deductive, but I will not go into that. And yes, there are still many problems related to the PCK which exist among teachers, and we are still struggling that how to work on that. Thank you.
Thank you so much, Jasmeet. It was indeed a very insightful presentation, and your work with BRC is something very important, as they're the crucial link between you and the teachers. So thank you. And now may I request Veena ji to present her work.
Just a minute, give me a minute. Yeah. Let me share the screen. Good morning once again.
Good morning.
Yes, are you able to see the screen, everyone?
Yes.
Okay, so I'm going to talk about mathematical thinking and using technology to foster mathematical thinking today. Before that, let me first introduce. Anyway, everyone is a math teacher, so everyone knows what exactly is math and how to go about. Everyone is trying to improve their teaching skill or teaching every day. It's a ongoing process. So math is a subject suitable for inquiry, not just memorization, as you all know. And it is a subject that can be learned by all students. I strongly believe everybody can learn math. It is not that, okay, oh, I am not good at math, you are very good at math. That kind of thing is not there according to me. I strongly believe that, and should be taught with an emphasis on processes such as problem solving, reasoning, communicating mathematically, and connecting mathematics to the real world. So effective math teaching occurs when we teachers foster mathematical thinking in students. So our aim as teachers is to make use of right resources to develop curiosity and interest first, and then make sure to provide conducive environment for learning. As the previous speaker aptly said, okay, she made an activity and all those things, yeah. So the procedure side of math definitely depends on the quality of creativity we have and also the quality of technique. Asking the right question at the right time and posing the right problem or starting the class with the right mindset, all those actually matter. And if you are, that is, if the teacher has the this one calculators, if they are allowed in a classroom, say for instance, if you are having technology, say if you have a white, this one, what is that, panel, the digital panels or calculators, they can actually be used as a tool to think with, rather than just as a tool to replace thinking. Just like, okay, just calculate this value, 2 plus 3 is how much, or 5, not just for using that, but you can actually introduce, let's say, for example, say quadratic equations. If you take the quadratic equations into consideration, and in quadratic equations, say b square minus 4ac is equal to 0, means the roots are equal and real. So those kind of things, actually you can approach it with the graphical calculators or graphing software, saying that, okay, showing different graphs of, say, y equal to 3x square plus 4x plus 7. Those are different graphs of quadratic curves, and linking it to, okay, if it cuts the x-axis, you can actually, they can actually visualize it. They can actually see the graph and say, okay, it is cutting the graph at, it is cutting the x-axis at 2 points. So there are two roots. So b square minus 4ac is greater than 0. And if b square minus 4ac is less than 0, it never cuts the x-axis. It is above the x-axis. Or if b square minus 4ac is equal to 0, it is just touching the x-axis. So like that, actually, we can make use of the graphic display calculator or any graphing software and show the students how it is related to, how geometry is related to algebra. Like that, we can actually make use of the technology to foster thinking, to foster mathematical thinking, rather than just using the calculator to compute. And also computation to investigate rather than just for calculation. For instance, if you are actually exposing the students to, say, the exponential number, you can actually ask them to calculate 1 plus 1 by n to the power of n for different values of n. And for smaller numbers, like if you take n equal to 0, then it will be just 1. If n equal to 2, it will be little higher. Like that it goes. And if you take 1 plus 1 by 10,000 to the power of 10,000, the number won't be just increasing, but it will stagnate at a particular point. And children will notice that difference. Yes, there is it is actually the value is not just going, it is not an increasing thing, but it is actually becoming a flat thing. It is becoming a constant, which is actually 2 point something. And that they can actually think and use for that. Okay, exponent, this is an exponential constant, this is e. Like that, we can actually use computation to investigate rather than just for calculation. Even if we have the exposure to computer, we can actually do so many math activities with the help of computer. Basically, I am trying to and I am trying to incorporate technology in math teaching. If we have the technology, definitely we can do wonders in math class. And also different routes which teachers take to make sure the concepts are built in. Ultimately, our aim is to make sure the students learn, students actually flourish in math. And also we try to foster mathematical thinking, not just for examination's sake. We try to actually do our job our job is to foster mathematical thinking. They have to think like mathematicians, not just for passing the examination. So we take different routes. Like we can actually start the class with the activity. We can start the class with a big problem, saying that, okay, this is the concept we are going to learn. So like that, we teachers actually try to build or try to foster mathematical thinking by whatever different routes we take. We should think in those lines instead of just preparing the students for examination. Definitely exams are important. Exams actually test their level of understanding, test their knowledge, all those things. For building that, we as teachers think in the lines such that, yeah, our students should think mathematically. By using technology, we can actually foster that. And some pedagogical knowledge a teacher must equip with is definitely the teacher should know math concepts thoroughly. It is necessary, but it is not sufficient. we need to use creativity and different techniques to make sure the students are learning whatever we actually thought of as learning objectives. We have to actually bring in those things in class so that students are that is most of the students, not I don't think we can actually achieve 100% thing in a class of say 30 or 40. At least we have maximum number of students are actually in maximum number of students, whatever learning objectives we have in our mind should be actually done. And we have to actually focus on instruction and a particular way of thinking, and definitely drill and kill is a method, mostly as the previous presenter showed, explain this and then they will just do the same kind of questions. So that's not the only thing, but that also is important. And for understanding the concept, the first, as the Bloom's taxonomy says, first we need to understand and then analyze, then actually apply, and then those things are definitely there. So we have to focus on instruction on a particular way of thinking and confidently use mathematical knowledge. That is, as teachers, we need to actually have this. And we have to focus on the processes rather than just the strategies. Okay, if you are given a plus b whole square, you have to use a square plus b square plus 2ab. Routinely, don't make use of that. Instead, how a plus b whole square, why a plus b whole square is a square plus b square plus 2ab, that we try to make the students think that way. Okay, a plus b into a plus b, how the factors are, okay, how to multiply, or how by making use of some lab activity or something, we can actually foster mathematical thinking. Go, okay, if the sum of numbers are there within this one, we will come, it's not just a plus b whole square is not a square plus b square, but it is this, like that. Even surface area or volume or whatever mathematical concept we have in mind, we have to use our creativity. And also we have to engage in reflective thinking rather than just monotonously follow. As I quoted, see, this, if this comes, you have to do this, irrespective of whatever. If you are having a plus b power n, you have to use the binomial theorem. How binomial theorem came into existence, why, what is its significance, where it is applied, those things, those kinds of things we need to think before going to the class. I strongly believe that. Thank you.
Thank you so much, Veena ji. This was a lovely presentation, and I'm so glad you made 3 very important points. That firstly, that is very close to my heart as well as a maths teacher, that everyone is good at mathematics. So as teachers, this is something we need to actually believe in very concretely. Yes. And the other thing that was very important that you mentioned was that one should be focusing on the process and not always be thinking about examination and the assessment. Yes, that's part of it, but what is more important is that children learn the process. And your attempt to integrate it with the technology is very, very interesting and meaningful. Thank you so much.
Thank you.
Jyoti, there is a question on chat for
we've decided to take all the questions towards the end.
Okay, let me check the question. Would you say?
If it's all taken at the end, it's fine. I just
we'll take it in the end. You can read the questions, and we'll take them up in the end. So now, may I please request Anuradha ji to present her work?
I am waiting for Ms. Veena to stop sharing. It's not letting me share. Yeah. Ms. Veena and Ms. Jasneet, thank you for your presentation. It was very enlightening. But you stole some of my words out of my mouth, so I'm going to skip those parts in my presentation.
That's the advantage we have if we are presenting first, you know.
Well, I'm third, so I'm counting on some bagging some.
No, but it's important to retaliate all those points again.
Yeah, you can.
Absolutely.
Yes, you can actually.
Yes.
Yes.
Ma'am, can you stop sharing so I can start?
Where should I'm
And the
looking-
top, there is a stop sharing button. If you can click on that.
Wait.
On the top, there's a green thing. Then there is a stop sharing. Do you see it?
I'm not able to find. Wait, I have to go to Zoom window. Yeah, talking. It is pause. It is saying pause share. Pause. I'm not good at this Zoom. I am very comfortable with. Where is it?
In the current screen, there is a button on top says stop sharing. Don't you see it? And there are two things on top.
So sorry, I'm not able to find. Now I came to this Zoom. This one. Where is it? View.
No, it stopped. Thank you. I think
Okay.
it stopped. Yeah.
Okay. Okay. Thanks a lot. Yeah.
Yeah. Able to see my screen? Yeah. Okay. So my presentation is about the emphasis on how to connect the real world applications into mathematics classes. But of course, the enthusiasm that Ms. Veena has towards the classes, I mean, that needs to echo through every lesson for it to be more effective. So I'm going to echo that point. But these are the research work that I came across when I was looking into real life connection, when there were these very real challenges that we face world over. So one is the focus on superficial keywords, like look for this particular word in the word problem so that you can identify which concept to use. So that is one thing that we reinforce in class, unfortunately, but they should be looking at the deeper meaning of the word problem itself. And secondly, the real life example that we lead the kids into might be a little bit adult for them, like going shopping is not something that they have to do. And if you are finding change for 12.84 rupees and you are buying something for 3.25 rupees, then that's not something realistic either, because we don't carry 0.84 in our, when we are going shopping. So when we are giving a subtraction problem, we should be aware that it should connect with what the student's background is. So that's where Joe Bowler goes. And it should be an open concept where the students have many answers rather than just one. I think Ms. Jasneet came up with that already. And usually the teachers are more worried about over-challenging the students, like what Ms. Jasneet was saying. It is not about the students not reaching the bar. If you keep training them, they will reach the bar. At least some pods will, and then you can push the other group of students to do the same. I will share more to show what I mean. In my past, a typical classroom, you're shown something, you're given like the 3 E's that Ms. Jasneet was saying. This is what I saw. But the problem is I am an engineer who shifted to teaching, and I still don't know where we use calculus. So it's a big query. Like I learned everything else in separate pods. How do you connect them? Where do you use calculus in all these engineering subjects that were taught? You know, it's a problem. Even after so many years, I'm still pondering that question. So unless students are given a way to connect, they are usually not able to connect. And the result of a typical math classroom, the last problem in the question paper will be difficult. And they all know that. And it's going to stay a problem. So because that's where we give a question with a twist, or we integrate two topics together. And we're trying to challenge the higher students, but the problem is many students will not be able to figure that out within the test requirements or the timing given. This is how I faced, as a student, how it was. Math. This is how math was for me. So again, Ms. Jasneet already said, reform teaching is considered more difficult than traditional teaching. So teachers lean towards traditional teaching at all times. And this is Gainsbourg. She put out a paper in 2012. And there are two methods that come out as most successful. Through what she says is testing soundness of a mathematical solution. 29% of the teachers accepted that was a very effective way to increase the level of thinking of students. Is this method better than the other method? So this would be a better question to ask during the class. And also high cognitive demand questions, like you challenge them, but you allow them the time and allow them the space to make mistakes. So again, I'm bouncing off of what Ms. Jasneet put out there. So the other one was institutions could actually practice the PLCs where peer learning communities are there, where the teachers share theories, but I'm going a little bit beyond just sharing good practices, but also to sort of collaborate across subjects. So this is what I'm doing differently, but many of them were covered, except the last one, how to solve a word problem. I teach them with 5 tools. It's reread. You are going to reread the problem. You're going to visualize the problem. So you're going to draw it out. And then you're going to chunk the problem, like break it down to smaller pieces. And then organize the material given, and then create the equation to solve it, and then solve. So when you give out techniques that are general, but they can apply in any particular word problem, it will be more useful for the student to use immaterial of the concept given. So they have to understand the deeper level of the question rather than just stay on the keywords. So I am applying that in my class. Now, I will skip over these because I want to get to the good part of my presentation and make it actually useful for other teachers. So this is, of course, limited to my experience and research that I conducted. So please bear with me. These are the different things that we'll be going over and how I change my lessons. Now, the teacher planning should basically include class explanations, introduction to topics. You can talk to your peers about this. Conceptual understanding, very important. Ms. Veena and Ms. Jasneet already took those words, like the conceptual understanding, the deeper meaning of where the problems or problem solving comes from should be covered in class. Subject integration is something I will go in a little bit of depth. Group discussions have to be scaffolded. That has to be the opportunity for group discussion should be made. So I will also show you that. And project work, most of it can be given as homework. So the trick is to make it easy enough for the students to handle it by themselves. And of course, self-assessments. Again, this was also covered in yesterday's one of the presentations that MTA had posted. So the teachers, we always have a year plan, a unit plan, and a lesson plan. So in our year plan this year, we sort of collaborated as the entire middle school team came together. So I have 3 year plans I have displayed here. One is the 6th grade one, where you see LCM and HCF concept. We sort of took that concept and in a mridangam, like a music collaboration there. So one of my students who is currently in grade 11 came out with the mridangam, and he played beats like takita, 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 takita. So those are 3 beats. But talam, an adi talam will contain 8. So where is the LCM there? Where will it meet? So within that particular 8 measure, how many 3 beats can you fit, and when will they meet? So 8, 3, 24. You need 3 of the talams to have the 3 beats finish. So that was something the students were writing ta, ki, ta, ki, ta. So they were working on the syllables. So music is something I learned in my past. So we were able to connect that into our math classroom. Ratio proportion can be integrated with art because everything is proportion in there. You take a Picasso's work, you measure it. There are certain artworks that have the same rectangular proportion all throughout the different parts of the art. You can show that, excuse me. Physics, chemistry, biology have formulae that you can show how. So in grade 6, we start with very simple formulae like F is equal to mg, S is equal to d by t. But these can be applied in mathematics class, not just leave it for the physics teacher to solve. And we have other things like art integration. The teacher is very cooperative. So we went ahead with the transformation, translation, reflection, enlargement. They do a stop motion movie with a particular doll at a particular place, and they have to indicate which mathematical position they are in. And if it is enlarging or like reducing, they like show what scale factor it is. And if they are doing translation, they like show how many points to the left or right. So is it plus x, plus y, minus y, based on a mathematical reflection from their stop motion picture. So these things were very useful. We tried it last year, it worked well. So planning to use it again this year. So this year we also, so the main thing is have a conversation with the peer learning, like the other subject teachers, instead of going out of the way to create lesson plans, bounce ideas off of them, because they might have some maths topics that they are doing in their class and you are also doing. You need not do it at the same time, but rather use the same vocabulary. So if you use the same vocabulary, as in the geography teacher does mapping, so she says, go walk the corridor up the stairs. So I say, walk before you fly. But if we say the same words, we always look at x comma y as the coordinate grid. You always walk before you fly. So right now we are using the same vocabulary so that we are like echoing between different subjects what we are doing, so that the students have reinforced, hey, this we learned in math class, this we already did in geography class, this in physics. So they see that math is everywhere and not just one subject. And we see the teachers echoing the same words, which is very useful as what I've seen. So these are, I just thought, if you want to see some of the activities that we have planned for this year, this is 8th grade. I recently did an index factor of the Richter scale. They're doing it in geography with the earthquakes. So whatever they are doing in the curriculum, use that. You can't, of course, use every topic, but have some of the links with other subjects. So this is one main thing I wanted to show today. So in my unit plan, I have created the main SOW, or the scheme of work, comes from Cambridge. I work with the Cambridge school. So we have the curriculum SOW come in and we make our tweaks for the unit planner, of course. But if we incorporate the lesson plan along with it, I found that I was actually using my unit planner rather than just sitting in my drive, not being used. So I added my lesson plan, as you see on the right-hand side, along with my unit planner, so that it is used in Coalition. The next thing was fractions. When we are doing fractions, we do the conceptual level. So there was an activity I did with the fraction frogs, which is a little bit different. We have an inch ruler and the centimeter ruler across each other, like right against each other. And they were asked to make paper frogs, like origami, paper frogs, and they were jumping. So 2 students would have the game and they would make the jump. So we were doing mixed fraction in grade 6 class. So they had to figure out what the numerator and the denominator of the improper fraction was. And so I made them use the inch rule, because the division, the denominator will be either 8 or 16. It's not the usual 10. So if we have some of the students do a denominator 10, we have some of them use denominator 8 or 16, so that the jumps are the number of divisions that they cross. So you are going into a very deep level of mathematics, like what is the numerator, what's the denominator, with a very simple activity. You will have to be very clear as to what the expectation is, but once you give it there, students can do it. All my students did this activity, and I'm thinking they learned more, like what is the numerator and what is the denominator. Of course, I use pizza and cookies constantly with fractions, and they say, ma'am, you're making me hungry, but I stick to my examples. It strikes with them. So
Anuradha, you have
exceeded my time. Sorry.
Yeah, but
Okay,
we are enjoying it.
Yes, understood, ma'am.
Run us through. Yeah.
Sure. So again, percent, the joke is you come across Miss Anu, she'll cut you into 100 pieces, it is percent. So it's something that you like address at a very basic level. This is the sheet I would give out as homework. So you break it down to small parts what the students can digest, and then give them the table, a sample table to fill it, and then reflection questions where they can like sort of fill it themselves. So more independent you make them, you scaffold it through Google Classroom. I put it out there. I'm still using my Google Classroom. So you use that for collection of things, and there is a private chat that is available in Google Classroom. So of course you can like make the connections and solve the problems. So it shouldn't be a big issue to connect with individual students. So these are the steps I already talked to you about. And one thing I wanted to is appreciate error analysis and sharing reflections in class. So if someone makes a mistake, appreciate, hey, thanks for making the mistake. Can you tell me where you went wrong? So that would be something I asked very often in a classroom, and that enables even the lower students to come up, hey, ma'am, I made a mistake. I made a mistake, and they want to share. And so that creates a very positive environment in the classroom. And and of course, your passion is infectious. So like Miss Veena, I saw her and I knew she was passionate about that. So when you show it, the students, it infects them and they want to learn math as well. So you be passionate and you will infect the students with it. So thank you. That's my presentation. This was a form that I took from my students. So this is how they felt it was awesome. So I just wanted to show that they have changed their attitude towards math because of how it was taught. So that's my presentation. Thank you so much for the opportunity.
Thank you, Anuradha. It was really infectious for all of us here as well, because you are amazing maths teacher. One can see that. And we would love to look at all these activities in detail. I'm sure we all would want to know that. So if you could share your presentation, and
I will do that, ma'am.
And yeah, we'll learn from you even more about all.
I was hoping MPA could have a panel where we could all post our activities that we are doing, like Ms. Veena and Ms. Jathni. They have their own ideas. If we could break it down to year-wise, topic-wise, make it usable for teachers, that would be really great. We have a website, we could use it. Thank you so much.
We do have a Blackboard publication, and I think we can take it forward from you. And thank you so much. It was really interesting.
Thanks for the opportunity. Thanks.
Yeah, thanks. So now may I request Sushant to present his work?
Hi, am I audible?
Yes.
Sure. Give me a second. Is my presentation visible to all?
Yes.
Okay, so as name says, innovative ways of using hypsometer and learning trigonometry. So this, hypsometer or clinometer, most popularly it is called as clinometer, is a tool which uses principle of trigonometry and similar triangles to find approximate height of some object. And this presentation will focus on innovative ways students and teachers have found during sessions in HBCSE. I used to work in HBCSE before, and now I work in IRISE project of ISER Pune. And we had sessions with some teachers and some students, and there they found some innovative ways of using that tool. And this presentation will include those particular things. About IRISE project is Inspiring India in Research, Innovation and STEM Education, is a 3-year collaborative program between Department of Science and Technology, ISER Pune, British Council, Royal Society of Chemistry, Tata Trust and Tata Technologies. This is our teacher development strand. What we do in teacher development strand is we conduct workshop for teachers. So there is phase 1. Some teachers are selected from phase 1 towards phase 2, and then those teachers become innovation champions, and they train. They go and conduct cascade workshop. The way we have done workshops for them, the sessions which we did for them, they replicate those sessions for those cascade teachers, and those cascade teachers then go to schools and conduct those sessions for their students. And now, so my session was in that particular, these workshops was about hypsometer and using hypsometer and clinometer. And the way I said hypsometer clinometer principle of it uses principles of trigonometry to find height of an object. So most of us might have seen this tool. This is a very low cost hands-on activity. So it includes one straw, a thread, a protractor, and a weight tied to end of this thread. Then, so how one uses it? It like observer sees, locate one object, observe it through this straw, measure the angle between this 90-degree and this thread, and that angle is called as angle of inclination. And then this is how it is used. So in trigonometry at school level, so it is one of the challenging topic for student to understand. Also, many teachers also say, okay, this is non-favorite topic of the student. Even when I used to teach to 9 to 12th grade student, I like that time I never had this kind of exposure. कि क्यों करते हैं? I used to say, okay, ठीक है, ऐसा है, tan ऐसा ही होता है. Okay, opposite upon adjacent ही है, याद कर लो, आगे बढ़ते हैं. ऐसे that I used to do. And most of the time student also ask, there are so many memes also ki, okay, one more day has passed without using tan or sine value of anything. So yeah, so that real life application is also not very much visible. So when I was designing this session, I was analyzing some textbooks. So my topic was triangles and trigonometry. When I was actually going through textbook, I realized these are screenshots from Maharashtra State textbook. These are expectation. If my cursor is visible, these are expectation in the first chart that solve example using trigonometric identities, solve problems like measuring height of a tree, width of a river bed, etc. using trigonometry. So these are expectation are from students after learning trigonometry, but and also there are in application part. So these applications are very good. Like they can actually connect it to their local context, their day-to-day life, which says ki, okay, these applications say angle of elevation, angle of depression, line of vision, all three terms are there. Similarly with NCERT textbook, they also have they have separate chapter for application of trigonometry, and majorly focuses on these applications, which says angle of elevation or angle of depression. The gap which I found was there was no way mentioned how one can measure that in reality. How one can measure those angles directly using it. Like how, like it seems very nice that it's lighthouse, tree, a bird sitting on a tree, that kind of applications are there. But a student, the examples are also like, okay, this is angle, this angle is made, okay, 45-degree angle is there, just calculate the height. And that's why I thought of this tool as to fill that gap. This tool gives hands-on experience. It is low-cost tool since the material is easily available. Another thing which I realized from teacher, they said, okay, when I was conducting session, the teachers were like, okay, sir, so in Marathi, they said, "Ami bahar jaun maths keलं." So classroom के बाहर ground पे जाके भी maths कर सकते हैं, बहुत कम बार experience किया है. And then it can be modified in innovative ways. This tool can be modified, which we will see in further slides. So this is how I explain them, okay, how to use clinometer or hypsometer. So first fix the object, observe that point on that object, then locate through the straw of hypsometer. The straw of hypsometer, at one end there will be observer and another end will be pointed towards the object. Then note down the angle. So angle will be this 90 degree to the thread of the object. And then use the formula, height of the object from eye level of the observer is equal to tan theta into d. D is distance between the object and the observer. And then add height of the observer till eye level in that reading. So there used to be discussion about why this is tan theta formula. So why formula includes tan theta. So tan theta is, that discussion usually used to say, okay, I used to ask you, okay, what is tan theta? Like how do you teach tan theta? So they say, okay, opposite upon adjacent. So I say, okay, this diagram I used to draw on blackboard in front of them. I used to say, okay, this is our hypsometer. This is our triangle which is made in, like, which is there. And this is right angle triangle. So let's see, okay, this is opposite side and this is adjacent side. So this is distance is d and opposite side is height. And that's how they used to realize, okay, tan theta yahan pe use ho raha hai. Then discussion upon why hypsometer angle of, so we measure this angle. So this angle is angle made by hypsometer is there. This darkened angle. This angle is considered, so uska jo value hota hai, uska tan value nikalte hain. And we say that this is angle of equal to angle of inclination. So so in classroom while explaining this geometry, I used to get so many replies from teachers why it works that way. So first was interior angle and linear angle wala thing. So the teachers used to say, okay, this is 90 degree in protractor, this is 90 degree in small triangle, and angle is common. So these three are linear angle along the hypsometer, that protractor, and angle of interior angle of triangle will also make 180 degrees. So this angle has to equal to the angle of hypsometer has to be equal to angle of inclination. There was another explanation which says parallel lines, which is to include. So these two are parallel lines. Okay, this thread of hypsometer and this line which is of object is also considered as, these two are parallel lines, and then these two angles are equal, then linear angle and angle of inclination. I'm just going a bit quickly because of the time restrictions. Then just a minute. Then also another example, another explanation which I got from students was similar triangles. So they used to see all these three small triangles, okay, this blue color, this yellow one, and then this triangle made by red line and black line are actually similar triangles. And that's how they used to decide, okay, this angle has to be equal to this angle. There was one sir in our session who actually came to me and he was like, okay, sir, this diagram was drawn, this diagram was drawn, and he took hypsometer from me, he stick it there, यहाँ पे ऐसे लेके सिर्फ बोर्ड पे लगा दिया उन्होंने, यहाँ पे ये जो सेकंड hypsometer पर साइड दिख रहा है, and he said कि ये देखिए ये वाले जो linear angle है वो 180 डिग्री होने हैं, तो ये जो एंगल और ये ट्रायंगल के अंदर के एंगल 180 डिग्री है, दिस एंगल इज कॉमन, दिस पर्टिकुलर, so 180 डिग्री होके ये वाला एंगल इतना ही होना चाहिए. So that explanation he gave, Nikum sir. Then different version I'm talking about, classroom incident of HBCSE, where I was actually doing a session for regional student from Jawahar Navodaya Vidyalaya, and they were students of 9th standard, and I thought of introducing trigonometry using this activity. That time students come up with when I explain them, okay, when you go towards the object, angle increases, angle of inclination, and you move away, angle decreases. So that time they said, okay, sir, what if the angle is 45 degree? So we get right angle triangle, isosceles right angle triangle, because of which the distance between the observer and the object will be same as a distance between eye level and the height of the object. So this way. So this will be right isosceles right angle triangle, and they actually skip trigonometry you doing this, and by 45 degree. And actually that impact of 45 degree I used in ISER Pune's designing this session. So I used to give we had sessions with like 60 to 80 teachers in ISER Pune. So handling such huge crowd is a bit difficult. So that's why I used to divide them in groups, and I used to give different challenges to those teachers. And those challenges were like, okay, first use usual way, जो आपको बताया गया formula. Then use so you cannot use calculator for this tan theta value. Then measuring height of their teammate was another challenge. Fourth was skipping the step of adding height of observer till eye level. So every time they used to add eye level tak ka height, and then measuring the distance by using angle of depression. So everywhere we used to talk about angle of inclination, but one group was given challenge of angle of depression. So some outcomes which I got from there. So 45 degree outcome which I also got from teachers. Then there were teachers who said कि okay 30, 60, 90 degree वाला angle से भी हम ज़्यादा अच्छे से कर सकते हैं because √3 and 1/√3 की values याद है. One thing I want to note that teachers were more into tan का value instead of like the way a student explained it कि isosceles right angle triangle tan पे जाने की जरूरत नहीं है. They were like 45 degree का tan 1 होता है इसलिए हम लोग वो दे रहे हैं, not because isosceles right angle triangle. Then angle of using angle of inclination and angle of depression at the same time. Understanding how this tool works, calculating angle of depression they did. Then they also added some tools like one teacher said, okay, sorry, is anybody speaking? Then
Sushant,
yes. 10 minutes. Yeah, I will just run quickly.
Sorry.
Yeah, not an issue. So just a few more slides are remaining. So this tool said they said okay, straw की जगह laser लगा के जमीन पे रख के calculate, they will calculate. Once teacher said he has fixed the hypsometer to a table in his school, and then they calculate angle of inclination. Some outcomes which these are some teachers which are doing angle of depression, some explanation of geometry, their discussion. Then outcomes of cascade teachers also. The teachers which got this training, they went ahead and they did it in their cascade. They also got some different outcomes there. One of them was the teacher forgot to carry measuring tape to measure the distance. Then they calculated with different things like hand or approximated the height. 30, 60, 90 was there. Then teacher said ki so experience of teachers that was like real life example hai, classroom के बाहर जाने वाला है और activity है because of which student will enjoy this, and also they can actually connect it to their local life. They provided some examples. My experience with students, recent experience with students was a bit difficult, different, I would say, because those students were coming after COVID, like 2 classes were skipped, and that time, so I had to skip that geometry part. I was like, okay, यहाँ पे ये ज़्यादा difficult हो रहा है geometry explain करना, so I had to skip that. But teacher said कि okay, they will manage somehow. And further plans are like teacher will be doing this activity in their classroom and encourage their student in thinking innovative ways, and we will be compiling those inputs from them. And right now the second semester, the trigonometry chapter will be in second semester. That's why they haven't taught it yet. We are hoping that they will be doing it. And thanks to HBCSE Math Education Group, Vigyan Pratibha Group of HBCSE, iRise team, and all the teachers and students who have done this activity and provided their outcome. Thanks, and your suggestion, open for your suggestion. And
thank you so much, Sushant. This was very, very interesting. And trigonometry, as you rightly said, is always a challenge. And there are acronyms, there are all sort of memes, as you said rightly. But this is actually, while doing it, children learn it better. And working with teachers on this was something very interesting. Thank you for sharing this. Thank you.
Thank you.
So next we have CCL team. And may I please request you to share your work?
Sure. Yeah, hi Jyoti, thanks for the opportunity to the whole MTA team, and also really happy to see Sushant's work, and that also remind personally our team's memory of working with this iRise project team and the teachers who have come, the Maharashtrian teachers who have come as a part of that workshop. And also good to see that they are doing some of this activity in the outdoor. In fact, our activity and in fact the work which I wanted to share with you all is also something on the same thread or the direction, you can say. So I'm Jay, and I'm part of a team of Center for Creative Learning, which is situated at IIT Gandhinagar. Maybe I can just show you the photograph of our the lab. So this is on the bank of Sabarmati. This is our IIT Gandhinagar campus, and here is what our lab looks like. So yeah, so and looks little bit messy, but yeah, this is how it is. And here is another photo, and the work which we all of are trying to do is this, trying to bring back the gleam in the eyes of our children. And today also the thing which I wanted to share with you is some of our experiences which we have done in the course of last 5 years, and also during these years we have built somewhere around 1,000+ activities, models, stories, which I just wanted, and the glimpse of that, maybe a chunk of that I wanted to share with you today. So what I want to talk with you today is, maybe I'll switch once again to my slides. So here is something which I wanted to share as a part of this few minutes I have. So giving a sense of wonder by creating a mathematical impression in the sand with some of very interesting objects, toys which we have built, and of course exploring involved math, geometry and trigonometry out of it. And for that, maybe I can start with this very simple thing, a toy. So let's say, for example, what you see, maybe I can show you on the overhead camera. So here I have is a spring or a spiral that you call. And if you look at from, and what is interesting about this, if you look from the top, you see a circle. If you look from the side, you look you find a sinusoidal curve out there. But the very interesting part is that, let's say, for example, if I roll it on the ground, if I roll it on a sand, what would be the traces it will mark on the sand? So maybe let me just roll it and have a, or demonstrate you what it might look like. So you see straight lines, tilted straight line. This is what you found out as the traces of this particular spiral, which is which I first tried to do. For me, it was an absolutely non-intuitive, and so was for the 6th year or a 6th grader student, or a 12th year, or an undergraduate, or the various teachers and faculty members. When we illustrate them, they found it absolutely non-intuitive. And why it's a straight line is the discussion of that is even more interesting, because you see this particular spiral, why it's making a straight lines into the sand, just because of the moment how much you move your angle with respect to theta in a circle, the height also linearly proportionally increase for this particular spiral, which is also the definition of a helix or a spiral. And that's why you see a straight lines which has been drawn on the sand. What is so even interesting about finding the pattern in the straight lines which we are drawing? So let's say, once again, let me show you this over an overhead camera. So the question which I also keep an open-ended for the audience who are watching there: do you find a value of pi in this particular straight line? This is an open-ended question I'm keeping for you. And the various few very interesting models which I have. So for an example, यहाँ पे हमने क्या किया है कि एक फिरकी के ऊपर एक धागा लपेट दिया है. What we have done, maybe I can better to show it on an overhead camera. So here I have a thread being stick on this particular object, and now let's say, for example, if I roll it, let's see what happens. So you see, now instead of a straight lines, you have a triangular lines, and this is nothing but the same spiral we have done. So what we have done, a half loop we have gone on a one side, and once again the half loop of that spiral has been stick back, and this is what straight line curves this triangular wave you are getting here. Very interestingly, now what I've done is, so I have this PVC pipe, and on top of it I have pasted a cardboard ellipse. So you see, if you look from this particular view, or maybe I can show you from the overhead camera, that would be better. So what you see is the ellipse being stick on the top of it. Now let's say, for example, once again, if I roll this, very interestingly, what you get is actually a sinusoidal curve. Absolutely interesting. And of course, there are a few further questions which you would like to wonder about, that how come, or how can we prove that the trace you are getting is a sinusoidal curve? So this ellipse is nothing but, let's say, if you cut a cylinder in a slant, if you cut the cylinder in a slant cut, the whatever ellipse you are getting, that's what we have just upscale it, and the traces of that you are getting. The interesting activity which teachers often used to do in their schools after attending this workshop, what you used to do is just roll a paper, make a roll of a paper, and just make a slant cut it, open it up, and what you see is actually a sinusoidal sine curve. What is the interesting part, trigonometric interesting part of that? How can you prove the curve you are getting is actually a sine curve, which is even very interesting part, and I'll show you some visualization part with the help of the Geogebra which we have done. Some few other exploration which one would like to do with this is, let's have, maybe I can just show you this, which give you a better feeling to you. So now, instead of ellipse, what we have done here is these are the tilted circles which we have pasted on the pipe of PVC. Maybe I can show you on the overhead camera. So what you see is ये चूड़ियां जो है हमने वो टेढ़ी करके यहाँ पे उसके ऊपर PVC pipe के ऊपर चिपका दी है. And now the interesting thing is, if I make a traces of this, and this is just a इसका just छोटा भाई है, yeah, ये वाला. This is just a smaller bangles on top of this PVC pipe. And now if I just tilt them, or I just roll them, this is actually not a sine curve. And question is, what is the curve being formed by this particular trace? Absolutely interesting. This is nothing but a tilted circles on a top of PVC pipe. Even few more interesting exploration would be here. What I have done is, maybe I can show you with the front camera view. So now here on this PVC pipe, what you have is a square. And if I traces, what would be the so the first exercise that just looking at this object, what would be the trace? Can somebody just guess it? And after what the curve you are get, can we have this argument, the reasoning and the visualization exercise? And maybe I can show you with an overhead camera the traces of this square curve. Yeah. All right. So you see absolutely different pattern, and this squares can be shown in this square can be stick with the PVC pipe in a different manner, because you see what I have done here is that the edge or the axis of a square is the same as the axis of a cylinder, but instead or compared to this, where what we have done is, तो यहाँ पे जो है हमने एक काजू कतली की तरह लगा दिया है, or in other sense this is a square, and what you see, the axis of both this particular pieces are different than this particular cylinder piece. And of course the traces, very interestingly, the traces of that would be different compared to what you have previously. So now instead of the same axis here, the axis of this particular objects are different. And here once again what you will get is actually a triangular wave when you stick your squares on top of cylinder, something like this. Absolutely interesting. So the journey, these things, how we have started sharing with this a group of teachers, students, and in fact as an open audience, is as a part of this 30-30 STEM series. And I'm not going into the reasoning part of or the detailing part of why you get this particular curve and how do you find the closed form equation for that, but I'll share you the links and the detailing of where we have discussed and some of the experience of doing this. So the program name was 30-30 STEM, which we published in this pandemic, during the duration of pandemic. We published in fact a 26 episode. In one of the episode, pi, this is what we have shared. Let me just go back to my slides once again and share you this detail. Yeah, here it is. Yeah. So some of the episodes were on, so the idea of this particular program was to know how we can explore the math and science, which is very much related to our life, and hands-on approach along with the sense of wonder which would like to give as a part of this program. So across the country, 1 crore people have watched this program, and the episodes are, for example, finding the lung capacity, the entire 1.5 hour episode only on this. Similarly, astronomy, the absolutely interesting mathematics and combinatorics with playing cards, math of music, machine, bicycle. Bicycle is something which I wanted to come back once again. Math in vegetables. So idea is, in this particular episode, we also discuss about if you cut a cucumber and give a slant way, open up its peel, that would be also the same sine curve which you saw on the sand. Coming back to the episodes, yeah. So here is an episode, pi ka hisab. This is where we also talk about this various mathematical impression these objects leave on the sand, and things related to that, the visualization related discussion to that. In this episode of bicycle, what was, so just because of we are talking about this mathematical impressions, we had this live. Let me once again come back to my front camera. We have this live discussion related to, we showed them the impressions of bicycle, and we asked them this particular very famous question: which way did the bicycle go? Let me just show you this picture once again. Here it is. Let me just find that, the bicycle wala photo. Okay. Somewhere I'm not able to. Here it is. Okay. Let me just go back to my slides. Okay, here you go. So here is the trace of the wheels of a bicycle. And the question which we would like to discuss here is, which way did the bicycle go, from right to left or from left to right, which of course leads to the various discussion related to the calculus, the geometry, and of course a few other mathematical things. And after that, we have several this in-service course for KVS and GNB teachers, where we would like to showcase some of this mathematical exploration. And idea is to get a sense of wonder with this hands-on activities, making sure that you wanted to make this with the help of PVC pipe and cutting out the shapes out of the cardboard, sticking them up, and getting wonder about this mathematical impressions, which is right around there. What next I wanted to also show.
Jay, I think we need to have a workshop with you. We are running short of time, and your ideas are so interesting that I'm
just
feeling
a couple
really
of
bad
minutes.
stopping you here.
Sure. So just a couple of minutes, and I'll just
yes,
sure.
please.
So similar to that, we have this. Let me just go back to the overhead camera. All right. So and what we have is, let's say I have a car, and all I wanted to do is just pull it back, and what you see is also actually a sine curve which it is forming. Let me just run it once again. So what we wanted to do it here is, all right, maybe from the little bit ahead so that I can show it to you. All right. So what you hear is a sine wave which is being formed by this particular car, and this is what, as a part of the workshop, teacher used to build this in a group. This entire thing comes out as a part of a sheet, which the pieces can be just come out of. They will make it as a part of a group activity in 30 minutes. And what you see is this particular pen, which can only move into this direction, where the car moves only in the, let's say I call it as a y-axis. This is an x-axis, and somebody says this is a harmonic motion what you are getting, and that's why the impression. But you see, the time is the trace of that is independent of time. There is no relation of time which is out there. You can move the car in whichever manner you want. And similarly, you have this another car, very similar another car, and this is the last thing. And after that, I'll just stop myself. So I have a very similar car, but instead of drawing the sine wave, let me once again go back to my overhead camera. And now what you see here, okay, little bit adjustment, and here you go. All right. So you see now this curved lines is translated into a sine waves. And lastly, what I wanted to share is that some of this work, this is just a glimpse of the things which I wanted to show you as a part of this 10-minute discussion we have. But most of the stuff we have put it on our YouTube channel, and the program, this 30 STEM, is just open. There were 26 episodes and various things we have discussed in detail. And of course, we would like to hear from any things you wanted to ask or have query, or things you wanted to suggest. Of course, this is our email ID. And most of this stuff we have also made it in a Geogebra, where the idea is to try to have this visualization exercises along with the physical models you build, or at least try to demonstrate them as a part of the Geogebra exercises we have. All right. So maybe, this is where we would like to just stop. And here is the Geogebra apps related to where you have make. So idea is that you have a car which drawing a sine wave or a triangular wave. But let's say if you wanted to have a car which would like to make a circle, how would you like to form it? Or similarly, you wanted to have a various sine wave being accumulated, which is nothing but a Fourier transformation and things like that. Yeah. So thank you very much for the, so thank you very much for the opportunity to share this.
This is very, very creative and very, very interesting. And as you said that it will bring the gleam in the eyes of children, I'm sure we all are experiencing it. If you could please share all those links on the chat box in case people want to, and we will definitely, Jam is here. Jam, we can have Jay for workshop with our teachers. So this is very interesting. Time was short, but I'm sure we all have many questions and insights about what you have shared, and we'll take it up towards the end. Thank you once again. Yeah, and now may I please request Nirupama ji to present her work.
Yes, please.
Thank you.
Am I visible? Okay. Am I audible? Hello?
Yes, you are.
Okay. Yeah, so good morning, everyone. I'm Nirupama. I'm a research scholar at Jamia Millia Islamia University and also a practicing teacher in a government school in New Delhi. I teach primary children. So, my topic today is mathematics and movement, Odissi dance and art and craft integration in mathematics at preparatory stage. So basically, I took class 4th. It has been discussed many a times here that there are certain issues with teaching and learning process of mathematics because of which mathematics anxiety is there, mathematics fear for mathematics is there, and many such things. And it has also been highlighted by NCF 2005 and now NEP 2020. And alternative approaches like arts integration and other activity based approach, they have been into practice. And now because an NEP 2020 also envisions like we need to have joyful classrooms and we need to integrate arts into teaching of all the subjects as an approach, as a pedagogy. So I took because yes, it's been years that I have been teaching primary kids, and I also observed that children find it very tough to take mathematics. I mean, to understand this, and when there is this mathematics test or exam is there, there is a certain kind of anxiety in them as compared to other subjects. So talking of, I mean, because I have been practicing AIL since many years, today I'm discussing one topic of class 4, that is angles. And I tried to incorporate arts like dance, Odissi dance we took, and art and craft activity, aeroplane making and flying into the class of angles. And I have tried to know what effect does it have on the basic misconceptions that children deal while learning angles. So general misconceptions around angles that we see at preparatory stage are like we give a prototype right angle to children. So when in different orientations it is given, children find it very tough to identify that if it is a right angle or not. Another misconception is related to different arm lengths. Like it is tough for children if different arm lengths are given. So children find it tough and to know which angle is greater, smaller, or are they equal. Next is different arc lengths. If different lengths, like you can see in the picture, this is C picture, अगर different हम arc length draw कर देते हैं तो बच्चों को लगता है कि जो greater arc length है वो angle बड़ा है दूसरे angle से. So ये कुछ misconceptions हैं जो मैंने अपनी क्लासरूम में भी देखा. They have been documented well in different research papers कि बच्चों को इस लेवल पर जो beginner level है इस पर इस तरीके के कुछ misconceptions जो होते हैं. तो डिफरेंट अगर ओरिएंटेशंस भी चेंज कर देते हैं तो बच्चों को डिफिकल्ट होता है एंगल्स को आइडेंटिफाई करना कि क्या वहां पर भी एंगल बन रहा है. एंड अगर राइट एंगल की हम बात करें तो डिफरेंट ओरिएंटेशन में बच्चों को ये नहीं पता लग पाता है वो मोर देन राइट एंगल है कि एंगल है कि नहीं है. सो ऑल सॉर्ट ऑफ मिसकंसेप्शंस आर देयर. सो बट बिफोर स्टार्टिंग दिस मैथमेटिक्स क्लास, what we did was we generally started doing this dance class. हमने ओडिसी डांस के कुछ बेसिक स्टेप्स को लर्न करना शुरू किया. दो आई एम आल्सो नॉट अ डांसर, आई एम अ जनरल मैथमेटिक्स टीचर. मुझे भी नहीं पता था, बच्चों को भी नहीं. वी सर्च सम बेसिक डांस स्टेप्स ओडिसी के, कि ओडिसी के बेसिक डांस स्टेप्स क्या होंगे, क्या बेसिक रिदम्स होंगे, और उसके हमने पोस्चर्स को और उसके डांस स्टेप्स को हमने मिलकर ट्राई किया, बिकॉज इट वाज अ न्यू लर्निंग फॉर मी आल्सो. सो इट वाज, ये बच्चों को बहुत ही अमेजिंग लग रहा था कि हमारी मैम को भी नहीं आता, वो भी हमारे साथ जो है लर्न कर रही है. सो हम ट्राई कर रहे थे उनको जो है करने का एज अ होल क्लास along with me. I was also doing this. So once we did this, हमने कुछ बेसिक प्रैक्टिस किया, कुछ जो हाथ हस्त मुद्राएं थी, जैसे मुष्टा थी, या होल बॉडी पोस्चर था, जैसे चौका था, त्रिभंगा था, और कुछ बेसिक मूवमेंट्स थे इन्हीं सब में. तो इन सबको हमने किया. पोस्ट दैट आई डिस्कस्ड दिस एंगल्स लेसन विद देम. जनरल एक डिस्कशन किया कि एंगल्स किस किस तरीके से बनते हैं और कैसे ह्यूमन बॉडी में हो सकते हैं. देन वी रीडिड दिस ओडिसी डांस मुद्रास, चौका, त्रिभंगा, हैंड जेस्टर्स, मुष्टि किया, मयूरह किया. ये करके देन वी आइडेंटिफाई डिफरेंट एंगल्स, कहाँ कहाँ पर जो है एंगल्स बन रहे हैं. लाइक अगर हम इस इमेज में भी देखें तो ये जो बच्चे की आर्म्स है, इसके बीच में ये पाम और आर्म के बीच में, नेक एंड दिस शोल्डर, देन दिस लेग्स मूवमेंट में, देन फीट एंड लेग्स, इनके बीच में जो एंगल्स है, हमने इन सबको डिस्कस किया. और ये किसके, उनको क्या लगता है कि ये राइट एंगल है, मोर देन राइट एंगल है, लेस देन राइट एंगल है, और क्या इसका करेक्ट पोस्चर करने के लिए हमें इसको थोड़ा और इस एंगल को मॉडिफाई करना होगा, टुवर्ड्स राइट लेकर आना होगा, मोर देन राइट एंगल लेके जाना होगा, या लेस देन राइट एंगल करना होगा, नेक का मूवमेंट क्या होगा. तो इस तरीके से हमने एंगल्स को इसमें डिस्कस किया. Post that हम अब next again it was an art experience, because ultimately they need, I mean of course एक relation है कि कैसे human body में या outside real life में कहाँ कहाँ पर हम angles देखते हैं. इन सब के discussion के बाद, because they have to come to this abstract aspect of this. So again I took this aeroplane making and flying activity. So I asked children to make aeroplanes of their choices. उन्होंने अपनी अपनी तरीके से जो aeroplanes को ड्रॉ किया और उसको जो है डिजाइन किया, कलरिंग किया, उसमें उसको डेकोरेट किया बेसिकली. एंड देन हमने एरोप्लेन फ्लाइंग एक्टिविटी किया. सो द आइडिया बिहाइंड वाज दैट दे एंजॉय द होल प्रोसेस ऑफ एरोप्लेन मेकिंग एंड फ्लाइंग. देन व्हाट वी डिड वाज, हमने इन एरोप्लेन्स को अनफोल्ड किया, और इनको अनफोल्ड करने के बाद बच्चों को ये बोला गया कि डू दे सी, जो पेपर की जो क्रीजेस हैं, क्या उसमें उनको कुछ एंगल्स नजर आते हैं. इफ यस, देन आई आस्क्ड देम टू ड्रॉ देम, कौन कौन से एंगल्स उनको नजर आ रहे हैं. सो ये कुछ इमेजेस हैं जो बच्चों ने आइडेंटिफाई की. ये जो सेकंड इमेज है दैट वी सी हियर, इस इमेज में बच्चे को जब राइट एंगल मिला तो उसने पेपर को टर्न करना शुरू किया ताकि वो डिफरेंट ओरिएंटेशन में और राइट एंगल्स को देख सके, और वहां पर उसने मार्क करना शुरू किया. सो शी टुक अ होल 360 टर्न टू आइडेंटिफाई कि कहाँ कहाँ पर जो है डिफरेंट एंगल्स जो है बन रहे हैं. ऐसे ही फर्स्ट इमेज में अगर हम देखेंगे तो यहाँ बच्चों को ये चैलेंज आ रहा था कि उनको जनरली लेस देन राइट एंगल उनको नजर आ रहे थे. देन दे आस्क्ड अ क्वेश्चन कि क्या मोर देन राइट एंगल्स भी इसमें है या नहीं है. तो बच्चों ने आपस में ही, बिकॉज कुछ बच्चों ने ढूंढ लिया था और कुछ बच्चे अभी स्ट्रगल कर रहे थे, तो दे केम फॉर हेल्प कि हाँ इसमें है, इसमें मोर देन राइट एंगल भी है जो इस तरीके से दिखेगा. तो किसी ने कहा कि क्या राइट एंगल है, because right angle as such directly was not visible because of the orientation of the angles. तो किसी बच्चे ने सजेस्ट किया कि हम ना प्रोटेक्टर का यूज कर लेते हैं, डी का यूज कर लेते हैं, जस्ट टू सी कि अगर कोई एंगल बन रहा है कि नहीं बन रहा है. सो दीज वर द वेज, जो भी प्रॉब्लम्स उनको राइज हो रही थी उसको सॉल्व करने के लिए जो वो सोल्यूशंस निकाल रहे थे, और अलग अलग तरीके से जो है वो एंगल्स को आइडेंटिफाई कर रहे थे. सी इस इमेज से बिल्कुल क्लियर है कि कोई यूजुअल एंगल आइडेंटिफिकेशन एक्टिविटी ये नहीं है. एक पेपर को अनफोल्ड किया है, उसकी जितनी भी क्रीजेस बन रही हैं उसमें जहां जहां पर भी पॉसिबल एंगल्स हैं उनको आइडेंटिफाई करने की कोशिश की है. सो दिस वाज अ डिफरेंट पेपर पेंसिल टास्क जो जनरली वो अपनी ट्रेडिशनल क्लासरूम में करते हैं, या बोर्ड पे जो क्वेश्चंस उनको दिए जाते हैं उनको डिस्कशन में जो है करते हैं. तो कुछ मिसकंसेप्शंस जिनकी मैंने शुरू में जैसे बात की थी कि ओरिएंटेशन से रिलेटेड होती है, तो ये कुछ एक्टिविटीज इस तरीके से थी कि ऑटोमेटिकली इसमें इनबिल्ट था कि बच्चे को डिफरेंट ओरिएंटेशंस में एंगल्स को देखना था, डिफरेंट आर्क लेंथ्स में देखना था. अब जैसे एक मैंने कहा था कि बताया, जैसे मैंने अपनी क्लास में पाया कि जब छोटी आर्क बनी होती है तो बच्चों को लगता है कि एंगल छोटा है, लेकिन वहीं अगर आर्क हम बड़ी कर देते हैं तो बच्चे को लगता है कि वो एंगल का जो है साइज वो इंक्रीज हो गया है. सो यहाँ पर बिकॉज ये फर्स्ट इमेज में अगर हम देखेंगे तो जैसे जब वो लेस देन राइट एंगल दिखा रहे हैं तो ये कुछ रेगुलर तरीका है आर्क दिखाने का, लेकिन जब उनको मोर देन राइट एंगल दिखाना है तो ऑटोमेटिकली वो जो आर्क है उसका साइज इंक्रीज हो रहा है। तो ये कुछ ऐसी चीजें थी जो नेचुरली इस प्रोसेस का पार्ट थी। पोस्ट दैट हमने इन सभी कॉन्सेप्ट्स को अलग से डिस्कस किया, कहाँ कहाँ पर उन्होंने एंगल्स को आइडेंटिफाई किया, उनको जनरली हमने जो है डिस्कस किया और क्लासरूम के ऑब्जेक्ट्स में और जो उनकी बुक में जिस भी तरीके की एक्टिविटीज दी थी वहां पर हमने हर in one way we took angles जितना possible ways हो सकते थे, जितना possible perspectives हो सकते थे angles को देखने के लिए, उन सबसे हमने इसमें डील किया। and for this assessment because yes I was doing this class observation कि बच्चे किस तरीके से engage हो रहे हैं, तो एक पैटर्न हमने फॉलो किया which was कि पहले हम आर्ट एक्सपीरियंस के तरीके से लेंगे, like when we were doing that Odissi dance learning session, तो उसमें I never told them that we will be doing angles on these postures and stuff. We were completely immersed in this dance activity itself. So ना बच्चों को ना ये पता था, ना मैंने ये अपने मन में ये सोचा कि इससे मुझे पढ़ाना है तो मुझे इनके पोस्चर को इस तरीके से करेक्ट कर देना चाहिए, या because we were only in the process of learning that those dance postures and we did that. So basically we enjoyed that whole experience. And post when they were doing this aeroplane making and flying activities, so it was not announced in the class that post that art experience will be doing this serious mathematics and this and that. So a complete so to say a complete experience was given because cognitively they were involved, affectively and psychomotor, where all three domains were actively involved in the whole process of doing the art experience. And then gradually we integrated the threads with the topic that I wanted to deal, I wanted to take in the class. So I observed the children were in between saying बहुत मजा आ रहा है मैम, मैथ्स की क्लास में डांस भी हो सकता है, मजा आ रहा है, आप तो डांस में भी मैथ्स ढूंढ लेती हैं। कुछ इस तरीके से बच्चों ने जो है अपनी चीजों को शेयर किया कि मैम ये तो हर जगह ही मैथ्स हो गया, अगर हम एरोप्लेन उड़ा रहे हैं तो भी हमें मैथ्स नजर आ रहा है, हम डांस कर रहे हैं तो भी हमें मैथ्स जो है इसमें नजर आ रहा है। सो of course they enjoyed this dance activity, and more than that they also enjoyed that कि हमारी मैम को भी नहीं आता है एरोप्लेन बनाना। आई वाज लर्निंग विद देम, एक बच्चे ने बनाया तो मैंने बोला कि मुझे भी सिखा दो। सो गिविंग इंस्टिलिंग कॉन्फिडेंस इन देम एंड एक प्लेटफॉर्म पे आना, वो जो हायरार्की है उसको जो है खत्म कर देना, एक कनेक्शन बच्चों के साथ बिल्ड करना कि यस हम मिलकर जो है कुछ चीजों को सीख रहे हैं, मिलकर हम किसी प्रॉब्लम को सॉल्व कर रहे हैं। सो and post that because it was आवधिक आकलन also periodic test हम कह सकते हैं कि ये classroom observation और ये सब activities करने के बाद इनका एक test भी था which was a formal exam, वो सभी classes का था, not just of this class। तो syllabus का part ही angles था। so उस test की जो grading है वो यहाँ पर है कि 19 बच्चे थे जिनको A grade मिला and post that। so more than that जो पेपर अंडरस्टैंड कॉन्सेप्चुअल बेस्ड था जिसमें मेजर क्वेश्चंस जो थे एंगल्स के वो डिफरेंट ओरिएंटेशंस पे थे कि बच्चे आइडेंटिफाई कर पाते नहीं, उनको पता चल रहा है कि नहीं वो राइट एंगल है कि मोर देन राइट एंगल है कि लेस देन राइट एंगल है, लाइक दिस। और किस तरीके से जो है वो कितने एंगल्स को आइडेंटिफाई कर रहे हैं, मैक्सिमम कितने एंगल्स के आइडेंटिफिकेशन तक वो जा पा रहे हैं, और डिफरेंट कौन से सिनेरियोज है जहां पर वो इनका आइडेंटिफिकेशन कर पा रहे हैं। सो इट वाज ऑल डेल्ट, वो क्वेश्चन पेपर के थ्रू जो बच्चों की ग्रेडिंग है उससे भी इसको रिफ्लेक्ट किया। सो इट वाज मोर देन I mean, I felt it was a complete process in the sense कि बच्चों ने enjoy भी किया and they learned also, और जो misconceptions generally हम देख रहे होते हैं इस topic से related, they were not there in the class. So yeah, that's it.
Thank you so much. Thank you so much, Nirupama. It was a wonderful presentation, and working with small children is a big task. And I've worked with primary students, and I know how angles and how they struggle understanding. And you have very nicely mentioned all the errors that come up during the primary years. And your integration with the dance and the craft work was something very interesting. I'm sure we can all go back to our classes and try this out. Thank you. So next I invite Ridhi and Mahima to share their work.
Good morning, ma'am. I'll just share the screen.
Yeah, hi.
Is the screen visible, ma'am? All right. A very good morning to one and all. I am Riddhi Bakshi.
And I am Mahima Kashyap. We are B.Ed second year teacher trainees from State Council of Educational Research and Training, Basant Kunj.
So it is a privilege for us to be here in front of such esteemed professionals. And now as we begin, so at the start of the COVID-19 pandemic, everyone struggled to adjust the new challenges posed affecting the lifestyle, the educational practices, the teaching and learning, with a major shift from the in-person interactions to the online mode. Even when the students and teachers adopted the sophisticated digital means to avoid lagging behind, nothing could replace the real inhuman interactions. The unprecedented damage that has been caused by the coronavirus on the mental health of the young students is just inexplicable, with lost interactions and ideas and thoughts and expressions. This in turn has affected the performances, and now it is high time that we as educators deliberate on ways to meet these challenges. So, as we continue to struggle with the uncertainties brought by this pandemic, the difficulties faced during this transition, we now need to reflect on several critical questions for the teaching learning process. So, as we move from the online to the offline mode, things are not as simple as they seem to be. There's a hustle to cope up with the classroom teachings and to enable engagement and preparedness with increased motivation. And today, my fellow mate and me are here to throw some light on the topic scaffolding learning recovery in face-to-face mathematics classes.
So firstly, what is the need to use the term recovery? Clearly, there has been a huge learning loss among students, be it of any level they may be in. Many reasons can be cited for this, and they have been thoroughly discussed in the previous sessions. So as discussed in the previous sessions, we'll quickly bat around the challenges faced whilst transitioning from online to offline mode of teaching. So firstly, we all know that mathematics is indeed a cumulative subject. Comprehending many topics requires solid prerequisite knowledge. It has been observed that questions or topics which require some rudiments of previously learned concepts, and that too specially taught in the online mode, pose to be difficult to understand. Students attended online classes at the comfort of their homes. Many a times they were half-heartedly present in the class. Maybe sometimes they were sleeping with their cameras and microphones on mute, or casually lying in their sitting area. This in turn led to loss of sitting capacity for long hours amongst them when they were physically constricted to formal learning environments. Thirdly, attention spans have decreased because online lectures and rise of digital media has enriched teaching, and traditional educational formats such as presentations and lectures need to be more engaging. Fourth point, maybe during discussions and assessments, the students experienced a sudden dip in self-confidence. The performance in the exams was terribly low compared to the online mode of exams due to loss of habit of writing on a daily basis. And fifth, maybe students face difficulty while expressing their opinions, because indeed there was a huge gap in between socialization. Students were not able to go to school. There were frequent lockdowns. So in fact, there was a gap between socialization. And the last point is students as well as their parents alike, they face trouble in managing their time. So what is the need of scaffolding here? So first of all, we'll understand the concept of scaffolding. Over the past few decades, scaffolding has been a promising technique used in teaching and learning. Indeed, the metaphor of scaffolding has been used as the name of a theoretical construct in the field of education. The term scaffolding is originally a construction-related term. The scaffolding in the building profession, if we recall, refers to the temporary structures used to help workers construct or renovate buildings. So on the similar line, scaffolding in classrooms is a method of teaching where a more knowledgeable individual provides a framework that allows a less knowledgeable individual to be able to think at a higher level that they would have been able to on their own. So the goal for the less knowledgeable individual is to eventually able to think at that level or complete a specific task on their own. So given the framework, it can include demonstrating how the task is done, explaining the overall goal, and helping with the most complex parts of the task. So through scaffolding, the learner may start by requiring extensive help and then less support until they are able to complete the task on their own. So it is vital for the more knowledgeable individual to instruct, model appropriately, and use questions to assist and to provide feedback. So quickly, we'll study the key characteristics of scaffolding. The first and the most important feature is that the interaction must be collaborative. However, not all types of collaborative support are considered or they are taken under scaffolding. Scaffolding should be provided only when needed and should be adjusted to the student's level of understanding. So instead of giving support right away, the teachers should act contingently. That is, the scaffolding should operate within the student's ZPD. In other words, the teachers or scaffolders should access the student's level of comprehension and work at the same or at a slightly higher level. Consequently, it is important for teachers to collect information about their students' level of competence. So this information is needed in order for teachers to be able to determine whether to increase or decrease the amount of support provided. So in addition, good knowledge of the subject matter is as important as diagnosing students' understanding. So an effective scaffolding intervention requires a deep understanding of the subject matter or the task in question. Further, teachers might use a variety of techniques to tap different learning styles and strategies. Like the work model we know, the Gardner's multiple intelligence we know. So because not all students respond to scaffolded help in the same way. And last and the most important characteristic of scaffolding is scaffold should fade. That is, be gradually withdrawn over time as the students become more competent. The pace of fading depends on the student's level of performance, of course. Closely related to fading is the transfer of responsibility. The student's responsibility for the performance of a task increases as the student's skills and confidence increase. So that is, the student should be able to gain ownership in their learning process. The next slide, please.
Okay, so after understanding the present situation, as we proceed further, getting across the difficulties and the challenges, we as teachers or as educators or facilitators, we need to be aware of the need and importance of scaffolding, especially in these post-COVID times. So the lockdowns of the schools to confront the COVID-19 effects has caused an enormous impact at both the societal as well as the educational levels. The structure, the size, or the economy, and the social and cultural abilities has produced differences in the learning opportunities for children from different backgrounds. So the school closure during the pandemic, it had produced unequal learning opportunities. The instructional time received by the students has also been disproportionate. The problems right now, as per statistics, is that about 1.6 billion children have been affected across the globe. And this is one of the major challenges that we are facing. Studies show that the learning loss could result in students achieving only 50%. You're talking about the mathematics classrooms in particular, as compared to that of a normal year. There has been a significant learning gap between the students and the teachers. So now here comes the incredible role of scaffolding to bridge those learning gaps that have been eventually created. So basically, scaffolding, it acts as a ladder and it has much support at the bottom, which eventually reduces as we move in the upward direction. Now, what is to be understood is that all ladders cannot be the same. And similarly, all the students in our classroom cannot be the same either. As teachers, it is our responsibility to acknowledge that there are individual differences and the progress of every student can vary. Some might climb the ladder very fast, becoming independent with their thought processes, and some might need a little more support at certain steps. So it is the teacher who has to mold herself with scaffolding, acting as a model in the beginning, then as a guide, with gradually releasing and eventually making the students independent.
Riddhi, I'm sorry to interrupt you here. 10 minutes are over. So if you could quickly wind up your presentation.
Sure, ma'am, sure. So basically, appropriate interventions of scaffolding will do the job, and scaffolding exists at three levels. The environmental provisions, which enable the learning to take place without direct involvement of the teacher. So following this, we can have the teacher being directly into the contact with the students through explanation, reviewing, reconstructing, and developing. Now, the environmental provisions, these can include the classroom organizations or the seating arrangements, which eventually tend to add to the effective learning of the classroom. Now, coming next to the explaining, reviewing, and the reconstruction, this involves the inevitable direct interactions. So, before teaching any new concept, that is before the commencement of the instructional process, it is incredibly important to activate the students' prior knowledge. Now, this can be done by various methods which are mentioned here. The placement evaluation test, which help us to analyze at what level the student currently is and what more steps do we have to take him to reach where we want that to happen. For example, we have a concept of rational number that is to be introduced in class 8. So now I should be aware as a teacher that whether my students are clear with the concepts of fractions and integers so that I can make them reach the rational numbers. Going next, ultimately, after understanding the concept, the level 3 of scaffolding includes the conceptual thinking, where the students can eventually solve the isolated problems. So this is basically the ladder of scaffolding as we have discussed. Now, what is to be noted is that teachers need to have the equitable access, because in the classroom, since all the students are not at the same level, so providing equality is no justice. We know the famous quote of Albert Einstein that if we judge a fish by climbing the stairs, so it would think that it is stupid throughout its life. So basically, we have to give the equity in the classroom, which would help the students get the resources what they actually need to succeed. And these can be some of the equitable responses that we can have to use random response strategies and ask questions and so on, as we have mentioned here.
So how can we help students and teachers cope up with the challenges of offline classes after a long period in online mode? So these mechanisms have already been discussed by our previous speakers, so we won't dive much into them. We can just read it. First is remedial teaching, and second is taking care of students' health, mental health, and prioritizing the 4 C's as mentioned in NEP, and professional development of teachers. The school can aid, can be a big aid into that by sending their teachers to various workshops and organizing workshops in the school itself. And fifth one is avoiding any lack of communication between parents and teachers and students, and in fact the administration as well. And sixth is integrating and correlating mathematics with other subjects at various stages, be it primary, secondary, or senior secondary. So these have been very thoroughly being explained by our previous speaker, so we won't dive into it much. Next slide, please.
So as we are eventually moving towards the end, we ought to realize that as teachers, technology can always add to be a cherry to the pie. So even in the in-person classrooms or in the offline mode, we can make effective use of technology. And there have been some pointers that have been mentioned here, various apps and smart boards in the classroom.
Riddhi, you may share the slide in the chat box, and we can move ahead because we are running short of time. And we have one more presentation to go and discussion as well.
Okay,
Yes, ma'am,
ma'am.
just a minute.
Ma'am, at the end, I really want to thank MTAI, you, ma'am, and our fellow speakers. We are just B.Ed teacher trainees, so we will be embarking on our journey of teaching journey. We have learned a lot today from our fellow speakers, and we will definitely take all those lessons forward with us. Thank you so much for giving us this opportunity. Thank you.
Thank you so much for coming over and sharing your work here. Thank you so much. So next, may I please invite Dr. Alok to share his work.
यस, क्या आप मुझे सुन पा रहे हैं? ओके। एक तो सबसे अंत में बोलना ऐसा लगता है सब कुछ खत्म हो गया, अब आपके पास बोलने के लिए कुछ नहीं बचा है चलिए, बहुत शॉर्ट में मैं बोलने का प्रयास। मेरा जो विषय है वो किसी मैथमेटिक्स के टॉपिक या एक्टिविटी से रिलेटेड नहीं है। मैंने ये जानने का प्रयास किया है कि जो अभी समय चल रहा था कोविड काल, उसमें जो ई लर्निंग से हमने विद्यार्थियों को ज्ञान देने का प्रयास किया, क्या विद्यार्थी उसके प्रति अवेयर या जागरूक थे या नहीं थे, ये मैंने अपने विषय का चुनाव किया। जैसा कि अब अभी आप सब जानते हैं कि अभी सबसे ज्यादा जो इंटरनेट का यूज किया जा रहा है, बिना इंटरनेट के हम कोई भी काम नहीं कर पा रहे हैं। और विशेषतः शिक्षा के जगत में, एजुकेशन के फील्ड में तो भी सबसे ज्यादा जो हमारी मदद की गई वो इस इंटरनेट के द्वारा हमने हमारे विद्यार्थियों को हमारे से जोड़ने का प्रयास किया, क्योंकि स्कूल सारे बंद हो चुके थे और हमारे पास दूसरा कोई उपाय भी नहीं था। तो क्या विद्यार्थी भी इस इंटरनेट और इस ईमेल, मल्टीमीडिया, www, वीडियोग्राफिक्स और ये जो बहुत सारी चीजें हैं, क्या इनके प्रति उनकी अवेयरनेस क्या थी, ये जानने का मैंने प्रयास किया। तो ये कुछ चीजें थी जो ई लर्निंग में आप देखते हैं। ऑडियो फॉर्म में हो सकता है, वीडियो फॉर्म में, एनिमेशन फॉर्म में, ग्राफिक फॉर्म में, टेक्स्ट फॉर्म में। अब ई लर्निंग को हमने दो पार्ट में डिवाइड किया है। एक, जब सामने वाला बोल रहा है, जो दूसरी तरफ वाला है वो उसे सुन रहा है, दोनों एक ही समय में ये काम कर रहे हैं। दूसरा ऐसा हो सकता है कि पहले से प्री रिकॉर्डेड कोई चीज आपने रिकॉर्ड कर दी है, उसको अपलोड कर दिया है, बच्चे बाद में अपने सुविधा के अनुसार उसे देख रहे हैं। दो तरीके हमने जो है वो अभी यूज किए। मैंने अपने इस अध्ययन के लिए 11 और 12, 11th और 12th के जो विद्यार्थी थे उनका चयन किया, और विशेषतः जो 11 और 12 यानी 11th और 12th के जो साइंस और कॉमर्स के स्टूडेंट थे, और उनमें भी विशेषतः जो गणित के थे यानी कॉमर्स विद मैथ्स और साइंस विद मैथ्स वाले विद्यार्थी जो थे, उनका मैंने चयन किया था। दो विद्यालयों का चयन मैंने किया और उसमें से 25-25 छात्र छात्राओं का मैंने चयन किया, और फिर उनसे एक जागरूकता मापनी, जिसे 5 पॉइंट स्केल पे मैंने उसे बनाया, और उनसे फिर उससे संबंधित उनके क्या विचार हैं ये जानने का मैंने प्रयास किया। और फिर जब उनके जो रिजल्ट आए उसको टी टेस्ट के माध्यम से मैंने जानने का प्रयास किया। उसके लिए कुछ परिकल्पनाएं या हाइपोथेसिस मैंने बनाई जो विज्ञान और विषय के विद्यार्थियों के कोई अंतर नहीं पाया था। बेसिकली मैंने इसमें नल हाइपोथेसिस का यूज किया था। तो अलग अलग स्तर पे छात्र छात्राओं के, वाणिज्य और विज्ञान के एक स्कूल के दूसरे स्कूल से, इस तरीके से कुछ मैंने अपने परिकल्पनाओं का निर्माण किया था, और फिर उन्हें इस जागरूकता मापनी के स्तर पर जाने का प्रयास किया। कुछ लिमिटेशन थी मेरे पास, मैंने केवल 2 ही विद्यालयों का चयन इसमें किया था और केवल 100 छात्र छात्राओं का चयन इसमें किया। और जब मैंने इस जागरूकता मापनी को उन्हें बच्चों को दी, उन्होंने उस पर अपने जो भी विचार थे वो मुझे दिए और फिर मैंने उसे इस टी टेस्ट के माध्यम से जानने का प्रयास किया। तो उसके अलग अलग परिणाम जो है वो मेरे पास आए। पहला परिणाम ये आया कि जो विज्ञान और वाणिज्य वर्ग के विद्यार्थी थे उनके जागरूकता स्तर में अंतर पाया गया, यानी विज्ञान वाले मुझे अधिक जागरूक नजर आए बजाय वाणिज्य या कॉमर्स के विद्यार्थी। सेकंड जो परिकल्पना मैंने ली थी वो मैंने दोनों विद्यालयों के स्तर पे ली थी। तो दोनों विद्यालयों के स्तर में भी मुझे अंतर में देखने को मिला कि किसी विद्यालय जो विद्यालय 1 था उसमें और जो विद्यालय 2 था उसमें उनके जागरूकता स्तर में जो है वो अंतर मुझे मिला। परिकल्पना 3 जो मैंने ली थी उसमें मैंने विज्ञान और वाणिज्य वर्ग के छात्रों को जांचने का प्रयास किया। तो छात्राओं को मैंने जांचने का प्रयास किया, उसमें भी मैंने देखा कि उनके जागरूकता स्तर में अंतर जो है वो मुझे मिला। इस तरीके से ये जो 5 परिकल्पनाएं मैंने ली थी और इनको अलग अलग स्तर पर मैंने जांचने का प्रयास किया और कुछ परिणाम जो मैंने आपको बताया, कुछ परिणाम ऐसे। अंत में केवल निष्कर्ष पे आना चाहूंगा कि अब निष्कर्ष ये है कि अभी आने वाला टाइम अब जो है वो भी ई लर्निंग का रहेगा, क्योंकि स्कूल चालू हो गए हैं, सब कुछ हो गया है, लेकिन फिर भी ई लर्निंग के माध्यम से भी हम बहुत सारा ज्ञान क्लास में हमारे एक लिमिटेड टाइम पे हम नहीं दे पाते हैं। तो इस ई के माध्यम से वो जो कई चीजें हम उन्हें सिखाना चाहते हैं वो उन्हें दे सकते हैं। तो हमें थोड़ा सा उन्हें इसके लिए अवेयर करना होगा, उन्हें समझाना होगा कि जो सामग्री आपको हम क्लास के अतिरिक्त देना चाहें वो यहाँ पर होगी और उसको किस तरीके से यूज किया जा सकता है। तो मैं समझता हूँ इससे भी बच्चों का जो है वो समग्र विकास जो है वो हो सके। धन्यवाद।
थैंक यू सो मच आलोक जी। ये बहुत ही इंटरेस्टिंग था कि आपने जो बच्चों की जागरूकता के बारे में जानकारी हासिल करी और उसके ऊपर हमें एक पूरा एनालिसिस पेश किया। तो आई एम श्योर ये हमारे लिए आगे के काम के लिए बहुत उपयोगी होगा कि हम ये समझ पाए कि किस तरह से हम बच्चों को और अवेयर कर सकते हैं और किस तरह से बच्चों को हम उनकी लिमिटेशंस भी जान पाए। अगर उनकी अवेयरनेस नहीं थी या तो क्या क्या लिमिटेशंस रही जिसकी वजह से
बिल्कुल और सब जगह होती है, हमको आगे बढ़ना होगा।
जी बिल्कुल, थैंक यू, इट वाज वेरी इंपॉर्टेंट, थैंक यू। नाउ वी कैन क्विकली टेक अप द क्वेश्चंस and this was I want to thank all of you. This was really interesting or the most interesting thing was that all of you have worked on ground with the students or with the teachers, और वो जो on ground insights होते हैं वो बहुत ज़्यादा helpful होते हैं हमारी समझ को बनाने के लिए. So now we'll quickly take up the questions. आप खुद से अगर if you want to ask the questions on your own, we can unmute you and you can ask the questions. Anuradha, you had a question, so you had a question for CCL.
Yeah, I had posted it in the chat.
Yeah, so if you want to ask it directly, you can go ahead.
Could I ask Ms. Nirupama first? Is that okay?
Yes, please.
Ma'am, thanks for the presentation. And it's awesome that you're working with primary students, applying what you are, researching. So one thing is the time available for us as senior teachers when we come into middle school and high school. There are restrictions on our time. We run on a treadmill. We have to complete these many things within these many. So that applies to all of us who are trying to apply mathematical, real-world applications into mathematics. Other teachers will immediately ask, oh, where is the time? So how would you answer that question? I mean, that would be for, sir, I don't know your name, CCLIIT, as well as Ms. Nirupama. So if you can answer that, I mean, how you would answer those teachers, I mean, how would you battle that on ground?
It's been 12 years since, I'm Nirupama. My video is not on, that's why, yeah. So it's been 12 years since I have been practicing AIL in my classroom. So there have been 3 batches almost that from 1st to 5th that have undergone this AIL. So a few things that we practiced. One, indeed we need some art experience, be it performing art related or visual art related, but we won't be doing it every day for every topic. What we'll be doing is we will be doing one art experience and integrating it to as many subjects and concepts as it easily can be. I mean, naturally, organically, it can be. Another thing is, indeed, there is a time constraint, and these days, as compared to previous years, I'm facing it a lot because post-COVID scenario is different. We need to cover as many things because this 2 years gap is a lot. So what I do is I plan my activity day, which is usually one day in a week. We do have a bagless day in a week. So what I do is I plan all my art experiences, be it related to visual or this performing art. We do it on that day. I take pictures, I take videos, I take photographs, and then later on during subject teaching, I integrate them there. So this is how I manage my time. Or in the zero period, we do a short activity like this dance activity in the zero period just after this assembly is over. We do it in 10-15 minutes and for the sake of fun and enjoyment itself. So in mathematics class, because it's only 40 minutes period, we just integrated but only by recalling the experience, what we did then and how we did like this. So this is how we go about that. Like this aeroplane activity, I collected all the aeroplanes. Once we had done that, so I collected them, I redistributed in the class, and then we did this activity. So this is how we manage the time, because see, there is no shortcut to learning. You also understand that because you also are practicing this. There is no shortcut. So one needs to be
Thank you,
all the experiences.
Nirupma, I'm sorry to interrupt you here. We have other questions to take, and we have a GBM lined up for the members. So yeah, thank you so much. And Anuradha, I hope you got the gist of her response. And Anuradha also had a question very similar to this for Jasneet. In the video, we saw a small group of students. How would the teachers be guided to run a whole class for the small group sessions? So Jasneet, if you could quickly respond to this.
Yeah, I just want to say when this was given for the field trial, another teacher, another RP, they did it with the whole class. But that was with the whole class group. And after that, this was a question we asked in the group, in the interaction, that can it be done in the smaller group of the students? Can they do it by themselves only? Ke ek bacha dega aur baki bache karenge. So earlier that they were not, that was not into their focus. They thought that teacher hi karwa sakta hai. But after that, they did it in smaller groups.
Right. Thank you, Jasneet. And there is a question for Ms. Veena. Would you suggest we use calculator in limited situations from grade 6? We currently aren't using it in middle school, afraid that they will use it as a crutch. So Anuradha has this question for you, Veena ma'am, that shall we provide students with the calculators, or how do you respond to that? Veena ji, are you with us?
I think she's not there.
Okay. Anyone else would like to respond to this? Okay. Any other question that any one of you want to ask from each other?
So Anuradha ma'am has posted some comment about physics and maths interdisciplinary.
Yes,
I wanted to ask her whether just wanted her to elaborate it so I can understand it.
Sir, you were talking about complementary angles. So when we teach refraction through a glass block, so that is a grade 8 topic. So when they are measuring with if you let them measure, they will measure the complementary angle, because they will not measure from the normal. So we do have similarities with other subjects also. So the emphasis on complementary angles can be explained in physics as well as the hypsometer, clinometer during the trigonometry. So thanks for that. That's what I meant.
Nice example.
Okay, I want to thank all of you. It was a wonderful session and it was a great learning experience. And I hope we can plan some other session, probably a workshop with all of you, so that our teachers can benefit more. And for next, I'm sorry I had to cut short many of you because of the time constraint. As we have a session schedule now, we have a MTA GBM scheduled, and this is only for the members. So if you're not the members, kindly register and be the members. And it's a great platform for all of us to come together and share our work. So the registration link is on the website of MTA. So please go ahead and register yourself. And as we are looking forward to expand our community even further. So I hope you all will register as a member as well. Also, we have a cultural program scheduled in the evening, and where you can choose whatever you want to do, anything of your interest, probably sing or show a dance performance. If you are an instrument player, if you're a photographer, show your talents to us, and it will be a joyous evening. We'll be culminating the MTA workshop with that cultural program. So if any one of you is interested, kindly put it in the chat box right away, and I'll contact you and we can organize. And then we also have a session in the on the policy, and you may find it interesting as well. So please do join that session also, panel on education policy, which starts at 3. So before that, we have a GBM, and the GBM links have been sent to the members. And I once again request all of you to please join the MTA Association. It will be a great learning experience. And thank you once again for such a wonderful session. Thank you.
Thank you for your patience, ma'am.